So this is the topic. So servers and services. Okay. These are the servers and services. So why I put that title? I made up this title, guys, to know different type of services and different type of servers based on the services. Okay. First of all, peer-to-peer. Last class we discussed about a operating system, right? What is an operating system? Operating system provide a interface to users, and runs user applications, runs an applications, provide an environment to run an application, interacts with your hardware. Okay, your operating system is nothing but an application. It's nothing but a software or a program which provide a user interface like a CLI, command line user interface. Okay, command line interface. Okay, or a GUI, graphical user interface. It can be a graphical user interface or it can be a command line interface. It provides an environment to execute other programs, run an applications, okay, playing games, and also playing games like this. That's the point. Type of operating system: simple operating system, network operating system. Simple operating system means it's a desktop type operating system, which is desktop type operating system generally for we run applications, we play games, we do web browsing. Okay, so we do writing programs. We can be a client to a server. Okay, we utilize the services. Utilize the services. That is our desktop operating system. Server operating systems, I said a network operating system or a server operating system. Server operating system types are provided certain services to the clients. Okay, like a web services. So there is having some built-in features or built-in roles or by installing certain packages or by installing some applications. Server can able to provide certain services. Okay, that is what we are extension part we are discussing here, guys. Peer-to-peer is a kind of work group model. Okay, you have a computer. Okay, you have two computers and connected, and so their computers, two or more computers are connected. They are able to share their information, share their resources. This is symbolic representation of a network, means devices are connected in the network represented like this. It does not mean it is we should connect in a which topology it is bus topology, right? It does not mean you are in the bus topology. Of course, it is a bus topology, but it does not mean bus topology. It is represent devices connected in the network. Okay. For example, guys, this is APC. APC contains some data. It share this data. It is share this data to the network. So what happened? So this VPC want to access this data. So through network, it can able to access the data. For example, I have a printer. The printer is connected to this PC. Okay. So this is CPC, this is DPC. So this printer is shared from here. So CPC want to take a printout from DPC's printer. So it will send the request to DPC. DPC send a print request to the printer. So what we are doing, we can able to access information or data or resources through network without any centralized control. So we are not maintaining any centralized control. Without centralized control, we can able to sharing information, data or resources between two or more system. That is called a peer-to-peer. Okay. So in that particular instance only, a PC act like a server. Like this is contains the data, this is accessing the data. It means it is a server and it is a client. This is having a print resources. I am accessing the print resources from network. Means this is a client and this is providing the print services. Okay, that is a server in the particular instance of time only, in that particular instant only. But there is no permanent server, no permanent uh, centralized control kind of stuff. So you want to take a permission from someone to access this printer, or someone to you don't need to take a permission from someone to access this data from other PCs. Means some third one. Okay, guys, this is peer to peer. Understand peer to peer? Next one is server and client model. What is this server and client model? There is a server and there is a client. Of course, for example, the server is a web server. All these clients will access the web services from the web server. Okay. So there is a one web server. Okay. What is a web server? This is a web server. This is web server provide a web services. Okay. So we can access web pages from this server. So I send a request. To access these web pages. I will get the web pages. Okay. So server provide a service. Client will access the service. Server provide a service. Client access the service. Example, web server having a web pages. It will give you through web service. Client use a web browser and access the web pages from web server. Okay. So this is the point. Guys, actually, I'm telling one more statement for server and client that opposes the first statement, means opposite of first statement. Remember guys, server never give you anything directly. Server never give anything to the client. Server don't give web pages to the client. DHCP server don't give any IP address to the client pieces. DNS server do not give any kind of any server's IP addresses to the client. VPN server don't give connectivity to the client. So what I'm talking? Simply guys, you have to give request. The client has to request to the server for a service. So client asks, server, I want a web page. I want your web page. The client should ask, I want a VPN connectivity. Client should ask, I want a DHCP IP address. I want an IP address. It will ask a DHCP server. I want an IP address. Okay. So it is client request for a service to the server. Server understand client request and give the response to the client. Okay. So server and client model. Okay, guys, understand server and client.
Yes, sir. Yes, sir. Got it.
Yes, sir.
So server provide a service, client access the service. Or you can say client request for a server service to the server. So client will send a request to the server. Server will give service to the client. Next part is, yeah, this is the diagram. Okay, guys, there is a several servers are there. How something become a server? How we can call that one as a server? That one, or it can be a machine, or it can be a computer, it can be a device. We are calling it as a server. So based on what it is providing to you, what is giving to you, based on that we are. There is a web server. Web server use HTTP, HTTPS protocols. How a machine become a web server? By installing servers built-in features like a Microsoft Internet Information Service, or a packages like a Apache HTTPD or Tomcat, Glassfish. So different type of applications, NGI, NIX. Okay, so different packages are there, different applications by installing into a machine, it is become web server. Similarly, file server. You can upload and download files. You can store files remotely through FTP. Okay, file server, FTP protocol in file server. Okay, DHCP server, DNS server. What is DHCP server? DHCP server assign an IP address to the client machines. For example, I have a laptop. When I connect it to my network, so obviously through network I will get an IP address to my laptop. Okay, DHCP server. DNS server, so domain name system. Okay, yeah, mind. Active Directory server, it's a domain controller, authentication server. WDS servers, Windows deployment server, which install operating system into client PCs through network. So you can install an operating system into 10 computers through network directly. We can able to install. Okay. Mail servers use SMTP, POP3, IMAP kind of protocols. How a server become a mail server? So by installing Microsoft Exchange application or a Zimbra package or application, it become mail server. VPN server, virtualization servers, storage servers, database servers are there. You know what is database server? If you install a application like a Oracle DB server application, Microsoft SQL server application, MySQL application, okay, like that, if you install any of this one, the server become a database server. Okay, guys, so server, we calling something as a server mainly based on what service it is providing. Is it providing a web services, file related services, DHCP services or DNS services, or authentication services or deployment services, mail related services, virtualization related services, storage or database services. Based on the service it is providing, we call that one as a server. And another hand, we call something as a server based on what operating system it is inside. For example, Windows servers. Windows servers we call as something as a Windows server based on a Windows Server operating system. You install Windows Server 2019. So then it is we call it as a Windows Server 2019 only. But even it is not providing any services currently, but still we call it as a server based on its operating system. Okay, Red Hat operating system is there, CentOS operating system is there. These are all Linux servers, Linux based servers, Unix based servers, IBM based servers, like different type of servers are there, including virtualization servers, also based on a operating system like Hyper-V server, VMware vSphere server, Xen server, Proximox V servers are there. So to make a machine as a butler server, like a virtualization server. Next one, guys. So first I told about services, the server based on what service it is providing. Next one is server. In generally, we are telling it is a server based on its service or it by operating system and hardware also. If you take in case of hardware, tower server, rack mount server and blade server. Tower servers are mostly look like desktop server type. Okay, this is a tower server. Mostly it is the tower servers are look like a this kind of stuff. So these are the tower servers. So each tower server having a different facilities are there. So larger the motherboard, multi processor support, not multi-core processor also. So we can put a 2-3 a processor on the same board. So then we can achieve. And SCSI mounts are there. SAS connectivity is also available, storage purpose also. But it is a single servers. So like that has your requirement, you have to put a multiple servers. It occupy more space and lot of cabling is required. Then we can use rack server, a rack mount server. So rack servers. These are the rack server, guys. Look at here. It is also a server. It is also contains motherboard, processor, and operating system. And there is a storage base. You can insert directly the SAS disk into that one to connect the storage. This one single rack. It is an entire rack size. Entire thing one is as a okay. What I am telling. If you see this next picture like this. See how he is inserting a rack and removing the rack from the data center. Okay, so it's compared to tower server, it reduces the space, not required more wiring capacity and all. Last one is a blade server, guys. Blade is a simple blade. One single blade is a one single server. It contains its processor, RAM, internal storage kind of stuff. But very less facility for a SCSI disk or SAS disk on it. Okay, because it will store always extra. It is faster than tower and rack mount, and it is utilize very less space also. This is a blade. Okay, so this is the difference between blade server and rack server and tower server kind of stuff. Okay, just go through once, you can get something out of it. Guys, next one is data centers. We see in a peer-to-peer. Peer-to-peer is a individual pieces, and next one is a server and client model. Next one we discussed about a different services provided from server. Okay, so based on that, we are calling that is a particular server. And in our operating system wise, hardware wise, also servers are there. And here it is a data center. Any organization means any reputed organization, any enterprise related organization maintains their own data center. The data center contains rack servers, blade servers. What is meaning of data center? Data center contains servers, rack servers, blade servers kind of stuff. Networking related components like a router, such as fiber optical cables, UTP, STP cables, host bus controllers, adapters, firewalls, like that. Network related components are there. So servers, network, storage, like different type of disk storages, SAS storages, NAS storages. Okay, so different type of storages in the storage part. Cooling system, power supplies. The cooling system, power supply written, but there is a missing 2 points, guys. Software. You're running a software. You're running an application in the data centers machines. So that's it is given as software. Need to monitor entire environment of a data center, both humidity, temperature, and oxygen levels. Okay, infrastructure monitoring is required. So monitoring what are the servers are there, what should be, what are the things are running currently. Okay, storage related kind of stuff. Okay, cooling system, power supply. So why we need a cooling system? Make sure they should not get more heated, and of course power supply, backup power supply also should be provided to data center. Again, guys, what is a data center? Contains nothing but a servers, applications, storage, networking, components, softwares are an application already at all. And externally, we need a physical protection, so net infrastructure management. Okay, backup power supply, cooling system, and all we have to maintain. Next part is our group and domain, guys. Okay, so compulsory check what is peer to peer, what is server and client, what is the different servers are there, so you can tell any points from here. Okay, and next one is what is data center. That's it. Yeah. And just told